Good day, class. You're welcome once again to another exciting video lesson on Master Science Guide. Now, in today's video lesson, we're going to be talking about another aspect of stoichiometry called the mass-to-mass relationship. Now, in our previous lesson, all right, on stoichiometry, we looked at more concepts, all right. We have also looked at limited and necessary events, all right. But today we are looking at something very special, and that is what the mass-to-mass relationship. The mass-to-mass relationship. Now, mass-to-mass relationship is another branch of stoichiometry that relates masses of elements or compounds. All right. So, without wasting time, we're going to be diving into questions that can help us to understand how this mass-to-mass relationship works. So, I'm going to be reviewing 3 to 4 questions for this video, and please, I want you to stay tuned. All right, and make sure you watch this video to the end. Okay, we're going to save the best question for the last, so do it to watch this video to the end. And if you have seen this channel for the very first time, please like this video and subscribe. Also turn on your notification bell so that anytime I post a new video, you'll be the first to get notified. All right, let's now dive into questions. Class, now let's take down this first question. Let us break down this first question. Example 1. All right, now the question says, how many grams of ACl will be required to react with 10 grams of sodium hydroxide? Now, in stoichiometry, there is something that is very important, and that is writing a balanced chemical equation. You must first of all write a balanced chemical equation. So, from the balanced chemical equation, that is what will give us an idea, all right, on how to go about our calculations. So, you must do it to write a balanced chemical equation first. Now, some questions, they are going to give you the already balanced chemical equation just for you to solve. Sometimes, what if you are not given, you should be able to write it out. Now, this is an acid reacting with a base, all right? So that obviously, acid plus base, this reaction is very common. It's going to give us what? Salt and water. Right? So, by the time we balance this reaction, what are we going to get? If we balance this reaction, this is what we are going to get. We put 2 here, right? We'll put 2 here, and then we will also put 2 this way. So it's balanced. So hydrogen is 4. No. Okay. 2. So hydrogen is 4 into 1000. So having balanced our reaction, now let us solve. Okay, let's solve. Now, for us, in trying to solve, we need to know the molecular mass of ACl and that of sodium. So when we do the calculation for ACl, we have ACl is equal to, right, hydrogen is 1 H1 plus Cl 35.5. When you do that, we have 36.5. Then that of NaOH, we have it as 23 plus 16 for the oxygen, O 16 plus H1, that's equal to 40. Now, let's convert 2 moles of ACl because this is 2 moles. Alright, this is also 2 moles, this is also 2 moles, but our concern is not with these two, it's with these two. So now let's convert 2 moles of ACl to mass, alright? So it becomes 2 times the molecular mass of ACl, 36.5, which will give us 73 grams. Then 2 times the molar mass of NaOH, which is 40. And when we do that, it's going to give us what? 80 grams. So now here's the area in which I want every one of you to pay close attention. All right, now from the balanced equation, all right, 73 grams of ACl, all right, is required to react with what? 80 grams of NaOH, sodium hydroxide. 73, all right, 73. See, so now the question, how many grams of ACl will be required to react with 10 grams of NaOH? So therefore, X gram of HCl will be required to react with 10 gram of NaOH. Now this one, what do? We cross multiply. So by the time we cross multiply, we're going to have 73 times 10 equal to x times 80. Now, we know that this x times 80 will give us what? 80x, right? So this times this will give us 730 equal to what? 80x. So at this point, what do? Divide both sides by 80. So 730 divided by 80 equal to 80x divided by 80. 80 cancel out 80. Therefore, x is equal to, now, 730 divided by 80. 730 divided by 80. So that gives us what? 9.125 gram. 9.125 gram. So therefore means that for 10 gram of NaOH, we need what? 9.125 gram of HCl. So the option is option A. That is the correct option for this question. Now, let's look at the next question. All right, class. Now, let us break down this question on the board. All right? Let us break down this question on the board. The question says, from the equation, which is this equation, calculate the mass of calcium hydroxide needed to react with 50 gram of ammonium chloride. So, this ammonium chloride, we should calculate the mass of calcium hydroxide, this, that will react with 50 gram of this. All right. So the equation is already given to us and it is balanced. So what we need to know now is that nitrogen N is 14, Cl remains 35.5, H is equal to 1, O equals 16, and is there any other one given that we have not touched? Then Ca, calcium, Ca equals 40. All of these parameters you will be given in an examination. All right, you'll be given these parameters in an examination. So now let's go from the balanced equation. What do we have? 2 moles, right? So we have 2 moles of NaCl, ammonium chloride, NH4Cl, and then we now have 1 mole of calcium hydroxide. Now, let us find what is the molecular mass of ammonium chloride. So, in doing that, we have NH4Cl equal to 14 plus 1 times 4 plus 35.5. So, by the time we put this in our calculator, we're going to have 18 plus 35.5. That is 53.5. Alright, that's our molecular mass. Then what's the molecular mass of calcium hydroxide? Now, this 2 is only affecting what is inside the bracket. So it's not affecting the calcium. So we have 40 plus 2 times 16 plus 2 times 1. So when we put all of this together, what are we going to get? 40 plus 32, 2 times 16 is 32 plus 2. That will give us 74. Now, 2 moles of sodium chloride, how do you convert it to mass? You convert it to mass by just saying 2 times the molecular mass, which is 53.5. And this, how do you convert it? Just 1 times 74, which will also give us 74. So this, when we times this, 53.5 times 2, okay, so this is 107 gram. So the therefore is 2 moles of ammonium chloride, that is 107 gram, reacted with 1 times 74 is still what? 74. So 107 gram of ammonium chloride reacted with 74 gram of calcium hydroxide. Now the question says, calculate the mass of calcium hydroxide needed to react with 50 gram of ammonium chloride. So therefore, 50 gram of ammonium chloride will require how many grams of calcium hydroxide? So we cross multiply. Alright? So by the time we cross multiply and divide, this is what we are just going to have. We're going to have x is equal to this times this. That's 50 times 74 divided by 107. Alright? So when we do that, this is what we are going to have. 50 times 74. That's 3,700 divided by 107, which will give us 34.57 gram of calcium hydroxide. So it therefore means that 107 gram of ammonium chloride requires 74 gram of calcium hydroxide. Therefore, 50 gram of ammonium chloride will now require what? 34.57 gram of calcium hydroxide. So which option has 34.57 gram? Option B. So therefore, option B is our answer. So that's question 3. Now question 3 says, what mass of water is produced when 8 gram of hydrogen reacts with excess oxygen? Alright, what gram of water is produced? Now, I told you in stoichiometry, you must first of all write a balanced chemical equation. So we already have our balanced chemical equation, hydrogen oxygen, to give us this. So this is 2 moles of hydrogen reacting with 1 mole of oxygen to give us 2 moles of water. But the question says, what mass of water produced? So what is the mass of water produced when 8 gram of hydrogen? So we are relating hydrogen and water by mass. Now, what is the mass of 2 moles of hydrogen? First of all, the molar mass of hydrogen. Hydrogen is a diatomic molecule, H2. So the molar mass becomes what? 1 times 2, which is equal to what? 2. Then water is H2O. H2O. That is 1 times 2 plus 16, which is therefore equal to, now 1 times 2 is what? 2 plus 16. That will give us what? 18. So for 2 moles of hydrogen, it becomes, converting 2 moles to mass, it becomes 2 times the molar mass 2, which will give us what? 4 grams of hydrogen. Then for water, we have 2 moles. So it becomes what? 2 times 18, which will now give us what? 36 grams of water. Are you with me? 36 grams of water. Now, therefore, from the balanced equation, it means 4 grams of hydrogen produces 36 grams of water. 8 grams of hydrogen, 8 grams of hydrogen will now produce what mass of water? See the question, what mass of water is produced when 8 grams? So we know that when we use 4 grams of hydrogen from the balanced equation, we are going to get 36 grams of water. So now, what mass of water is formed when you use 8 grams of hydrogen? So you're going to cross multiply. So 4 times x is what? 4x, which is equal to 36 times 8. So at this point, what do we do? Divide both sides by 4. Divide here by 4. So 4 cancel out 4. Therefore, x is equal to, now if you put this in your calculator, this is what we are going to get our final answer. So when you do this with your calculator, you have 36 times 8 divided by 4. That is 72. We are going to get 72 grams of water. So the answer to this question is option A. Option A becomes the answer. Now let's look at the final question. This is the final question. It says, how many grams of HBr, how many grams of this would exactly be required to react with 2 grams of propane? This is propane. So this is already the reaction given. Now, if you are to balance this reaction, we have three carbon, hydrogen here 6, hydrogen here is 4, but 1 here. So if I put 2 here, comes 2 and 4, that's 6. Then 2Br, 2Br. Now, this is the masses of the elements we're giving, the molecular masses, all right, of the elements we're giving. So let's convert one more propane to mass gram, all right. So propane is C3H4, that is 12 for carbon, 12 times 3 plus hydrogen 4 times 1. So 12 times 3. So 3 times 2 is 6. 3 times 1 is 3. So that's 36 plus 4, which is equal to what? 40 gram per mole. So this is the molecular mass of propane. Then for HBr, so we have HBr, that is what? H is 1, so 1 plus Br is what? 80, 1 plus 80. So that gives us what? 81 gram per mole. So this is just the molecular masses of them. But now, this is 1 mole of propane, 2 moles of HBr. So 1 mole of propane. Now, because it is 1 mole, now what is the molar mass of propane? 40. Now, 1 mole, the mass, listen attentively, the mass of 1 mole of the substance is equal to the molecular mass. So because this is 1 mole, so I can say 1 times the molecular mass 40. 1 times 40 is still what? 40. So we have 40 gram. So the mass of this guy is 40 gram. Then it is 2. So it becomes 2 times 81. That will now give us 160. Sorry, 162. Because 2 times 1 is 2, then 2 times 8, 16. So 162 gram. So therefore that means now we can come and start solving. So it means that 40 gram of propane needs 162 gram of HBr. Therefore, 2 gram of propane, we need what mass of HBr? So let's cross multiply. All right, so by the time we cross multiply, we're going to have x is equal to 162 times 2 divided by 40. So when you just put this in your calculator, we're going to have 162 times 2 equal to 324 divided by 40. That is 8.1 gram of HBr. So therefore, it simply means that 40 gram of propane is going to need 162 gram from the balance equation. Then 2 grams of propane, we need what? 8.1 gram of HBr. Now, thank you very much for staying up to this point of the video. Now, for those of you that stayed up to this point of the video, I'm going to drop a secret formula that you can also use to get your questions, to answer questions on mass to mass relationship. Now, there is a secret formula I want to give to you. So this is a secret formula I was talking about. Now, you can also use this formula to give you your answer for mass to mass relationship. It is the mass of known over the mass of unknown, then the molar mass of known times the number of moles in the equation all over molar mass of unknown times the number of moles in the equation. Now, remember this question, the balance equation was C3H4 plus 2HBr to give us what? C3H6 Br2. Alright, so the mass of known, we know the propine, the mass of, so propine is the known because we know the mass in the question. So mass of known is what? 2 grams. So 2, that's for the propine. That's why it's the 2 over mass of unknown. Alright, so this guy, we don't know this. Alright, so we call it X. We are looking for the mass of the unknown, so we call it what? X equals to molar mass of known. The molar mass of this guy is what? 40 times number of moles. From the equation, how many number of moles is with propine? Just 1. So 1 all over molar mass of unknown. This is our unknown. We are looking for the mass of this. So mass of unknown, that's what we are looking for. So molar mass of unknown, this guy is what? 81 times the number of moles of this guy in the equation is what? 2. So 2. Alright? So it becomes what? 2x equal to 40 times 1 is 40. Then this guy will give us what? 162. So by the time we cross multiply, we are going to have what? X is equal to 2 times 162 all over what? 40. So when you still do this in your calculator, you're still going to have 8.1 gram. So you can use this formula method for any of the previous questions you have seen. So you can take this formula now and take it back to example 1 and begin to try them. Alright, you see that it's going to give you what is correct. Please don't forget, do not omit this number of moles, very important. And you get this number of moles from the balanced chemical equation. So thank you very much for watching this video to this point. I really appreciate it. Please do well to subscribe, like, and share this video to your friends. And I'll see you in the next episode.